All right, for this section, we're going to go ahead and solve logarithmic equations and exponential equations, solve and then go from there. And in each case, we are also going to write all the restrictions for each of the equation as well. All right, let's just start with the number 1 or A. So let's go ahead, and the idea is this. When you solving logarithmic equations, you're solving for a variable x. So here you go. That's the x right there. So the first thing first, let's simplify. We're going to put it back into original form. So 2 log x is basically log of x squared, that's base 10. And then that is addition of 2 logs, same base, that's multiplication. So log of 32 times 2. And notice that both of these guys, they have the same base. And the base in here is 10. We don't write it, but it is. All right. So if you have a situation like this, if both the left hand side and the right hand side, they have the same base and they're both single term, we can say by default that their argument must be the same. So we can actually now write that x squared must equal to 64. Simple as that. And then from this point on, we're going to solve. That would be plus or minus 8. We're going to take the square root of both sides. Here it is. You know, grade 10 stuff. And then, so we got that. Then you need to check your answer. So check. All right. So notice a couple of things. Restrictions. Before doing that, check for restrictions. So check. So this is check for answer. But what I meant was that what is the... So let's do restrictions first. So for the first thing that you notice that x must be greater than 0. It's right up front. The argument of log must be greater than 0. So we know automatically that we cannot have x cannot be equal to minus 8. So the minus 8 is out of the question, but x equals to 8, that works, and that is our only answer. Okay, simple as that. Let's go to example B. Let's rewrite this in terms of a single log and then change it to the exponential form and come back. So here it is. We have an addition of logs, same base, that is multiplication of the argument. It is base 10. We're going to change that now into the exponential form. So here is the change. Remember, that's 10. There's a 10 in here that we don't write. So 10 to the power of 1, or sorry, 10 to the exponent of 1 equals to the argument. So that would be x minus 2, x plus 1. Okay? That's what that would be. So now that we have that, we need to expand that and then bring everything to one side and solve the equation. In this case, what we'll have is that 10 equals 2. That would be x squared minus x minus 2. Now bring everything to one side. X squared minus x minus 12. Set that equal to 0. And now notice that your logarithmic equation turned out to be a quadratic. Okay, log value is gone. We change it to exponential, and that's what we end up getting. Okay, now here, couple of ways of doing this. We can use factoring, you can use quadratic formula. Whatever you decide to do, make sure you're consistent. And here it is, I'm using a quadratic formula. In this case, x equals to 4 and x equals to negative 3. Then you need to check. So before checking the answers, let's write up the restrictions for the domain for each of the... Remember, you're going to go back to the original. So x minus 2 is the original argument for the first term, and then x plus 1 is the argument for the second term. So x minus 2 has to be greater than 0. That means x has to be greater than 2. And then next one was x plus 1 must be greater than 0. That means all x values must be greater than negative 1. And between the two, you notice that x greater than 2 covers both cases. Okay, so that is your final restriction. So final restriction star is x greater than 2. That's your final restriction. Great. Now you go ahead and check. Notice that that is one of the solution. However, when x equals to minus 3, that is not a solution because it is not greater than 2. So the only answer is x equals to 4. Simple as that. Great. All right, let's look at C. Okay, let's call that equation C. Solve. Let's write the restrictions right away. Just get that out of the way. Restriction. In this case, we only have one of them, so x has to be greater than 0. Great. Now, the way it's written, I need you to be able to read this properly. This log of x base 9, that is the argument of the log of base 2. Okay? So another way of writing that is 2 to the power to the exponent of negative 1 equals log of 9 base x. Okay? So log of x base 9 is the argument of the first log. Great. Now that we have that, we're going to solve for x, change that to the exponential form. So it goes 9 to the power of, now 2 to the negative 1 is 1/2. Okay? So remember that you're flipping, so negative exponent, that's 1/2 to the power of 1. So 9 to the half equals 2x. And what is the half as a rational exponent? That's just a square root. So that basically 3. And excellent. And when you check that, so you check your answer. Okay, and when you plug the 3 in there with the log, and that should give you the value of negative 1. And it will. Okay, so that's very good. Excellent. Okay, let's look at 2 more. Actually, let's start with the exponential one. Okay, so we call that D. All right, so notice that the bases are all different. We have a 5 in here, we have a 2 and a 3, so we really can't do anything except using logarithm. So here, this is how you actually use the logarithmic laws as a function to help you to solve. So when I say function, I mean as an operation, algebraic operation. So in this case, this is what you would do. You would take the log of both sides. Simple as that. So we'll go ahead and we say log of 5 to the x plus 1 equals to the log of 2 times 3 to the x. Okay? And when we do that, we're using a natural log. That means log or common log, sorry, in natural base 10. So now we have the log on one side and log on the other side. Now we're going to go ahead and simplify. So the very first thing is that we need to get rid of the exponents by using a proper log law. So let's go ahead and do that. So this is what you will get. Okay, so we have this x plus 1 comes to the front, and then log of 2, that's a multiplication, that means addition, right? So there's a multiplication in there, that means addition, and then the 2x comes to the front as well. That's 2x comes to the front, and then that's what you will get. Now we need to go ahead and simplify, and in this case you just have to basically multiply through. Make sure that in this case x is multiplied by log 5 and 1 is multiplied by log 5, and expand and then collect like terms. So that's what you will get. Okay, simple as that. You will get a setup like this. Now we have, notice that what we have a log x log 5 and 2x log 3. So those are actually considered to be like terms because they have x in them. We're going to put them together. We're going to move all other log terms without x to the other side. Here it is. Okay, I subtracted 2x log 3 from both sides. That's what we will get. And in this case now, we need to factor x out of the first 2 terms on the left hand side. So when we do that, what do we get? We get x out log of 5 minus 2 log of 3 equals log of 2 minus log of 5. That's what you will get. The last thing you do, you divide everything by the coefficient. Remember, this 2 times log 5 minus 2 log 3 is just a number. So you have to divide both sides by that number, whatever that number is, and that will be your answer. And when you do the simplification, remember log of 2 minus log 5 is log of 2 divided by 5, and then log of 5 minus 2 log 3, it is log of 5 divided by log of 3 squared, which is 9, or sorry, 3 squared, yeah, log of 3 squared, and that would be 9, and then you can use your calculator to come up with the final answer. And that is it. So the last piece is the restrictions. Do we have any restrictions? No, not really, because x is not the argument of log. So you're safe and there are no restrictions. The only thing is that you check this regardless to make sure that it works, and if it does, which it does in terms of numerical value, then you're done. If it doesn't, then that becomes an extraneous root, which you know what that is, going back to the polynomial functions.